Hello and welcome, and we continue writing our own parser in C++ for DBML, database markup language. And in the previous episode, we managed to parse the project definition. So let's check our test DBML file. We have this project definition here. And for now, we don't store it anyhow. We just print it out from the parser, but we'll get to storing things later. For now, we want to parse them. And let's see. So today I would continue just trying parsing different structures here. And one of the simplest, I guess, is the enums. They're really simple. If we go into enum definition, it's just enum, the name, the curly, and then entries. And entries might have nodes associated with them. Yes. And you see, they can belong to schema. For now, we would just make and parse enums without this. And we instead would do this thing with schemas when we go to parsing tables, as it's kind of important here, but we might implement it later somehow somewhere, because it's similar how we would parse the name, like the fully qualified name with schema and stuff for enums and for tables, and then even for maybe relationships, those things here. This is really similar, so we consume like an identifier, and if we see a dot, we consume another one, and so on until we don't see a dot. And yeah, so this is how we do it. And you see, we might have quoted entries here, or we might have just regular words. And the same is for names. Let's try to define some enum here. Enum, well, let it be simple. Enum color, and we might have like red, blue, green, red, green, blue. Yes, and this might be quoted. Yes, but not like this. Yes, cool. And this also might be quoted, but not like this, and of course not like this. Right, and we might have a node in those square brackets, and the node is just anything. It's really like the node in table in project definition. So let's in advance edit our file and add some enum here. Maybe we would even copy it from here. Why not? We already have a node here. We would add, oh, sorry. We would add, and why it is two spaces? I want them to be four. So we would add a quoted thing. Yes. Okay. And I a bit played with Vim configuration, so we might continue writing in it, because I added those line numbers, and I also got to know how to navigate through files from inside it. So it's easier to work with multiple files then. Anyways, let's then try to modify our parser and see what we can do with it. So we have this consume project, and we would have a really similar thing like consume enum. So let's create this function. it would be also for now void consume enum. And what we need to do, we just consume, we define some things here. Okay, so we consume, what's going on? I got something wrong with my indentation here. Yeah, this is better to consume. And we want what? We want a name for it. So we do something like this, but we really expect it. So if it's none of those, then we should throw an error. So we say if peak is word or peak is quoted, then or probably instead we would inverse it, so we throw an error here and not big is, if it's neither of those, we say, or we just exit for now this exit code, and otherwise we say your name is peak value, and we consume. Now we have to consume curly. Let's see how it's done here. If it's not a curly, we also exit. I think we might do something like or write as consume and give give it a token type. So if peak or if peak is type, we just consume, otherwise we exit. Yep. And now we can use it. So here, if it's not a curly, we just can say consume curly. And we might do something like, so we can get this value if we supply a number of types. But for now, we'll leave it. So here we would also replace it with consume curly close. It's like a requirement. And we might want to then also have a look at this, because it kind of makes a really long check. And if we would then at some point try to report an error, it would say the error is right after the right at the beginning of, if you have this project definition, or this project definition, it would, if for example it's not a string or word but a number, it would report the error somewhere here and not here. But this is getting a bit far. By the way, can we have a number as this database type? Or we probably can have only a string, right? Right, good. And can we have a table name number? No. All right. Okay. So let's get into the enums. So what we, yeah, here we consume a word or a token. And we got the name. Now we consume curly open, and now we just loop until the curly close. So we do something like here, if while we get a value and it's not curly close. So, and we need a list of those entries. And the entry is actually not that simple, because it has just the name of it, but it might have a note associated. So for now, we might just do using entry as, by the way, I don't know, do I have to include the pair from somewhere? C++ pair. In utility, do I have to include it? We'll see. We'll see. Pair, and it's string view the name, and now optional is for the note. Now we have just a vector of those entries, and we say while we get something and it's not the curly close, then we try to parse an entry. So we need again to consume a word or a quoted thing. So if pick is also just exit for now. So if it's a word or quoted, then we say we can already do like yes, I will also, we already have the name here, right? Probably let's rename it to a num name. here the name is, or here will be entry name is peak value, and we check if, and we consume. Now if peak is bracket open, then we also consume the node. We would say node. And if it is, then we consume. And we expect it to be, can we have empty one? We have like, yeah, we can. And can we have, no, node can only appear once. All right. So we say something like we do here. We get the keyword. Do like this. So if it's a word and there we got a colon and there is any string, then node is how we do it actually. We consume and then all right. We don't have to check what keyword it is, so we have to say if it is a word and peak value is node, then node is, we say consume to, and node is peak value, and we consume it as well. And we consume the bracket closing one. Yes. This is optional. Yeah, this is okay. This is okay. And we have to, at the end, push back. We say entries, push back. And how we do it, make pair. Like this. Maybe. And now we would just print it. So and then go through entries. If it got a node, we also print it. New line, and then just the closing curly. And now we have to modify the consume or the parse. So if it's a project, we consume project. Else, if it's enum, we consume enum. Yes, and we might try to run it. So we need also this alias run is to make build and build DBML parser. I misspelled. I misspelled the enums. And trees. And I also forgot to add those STDs. To see out. Right. Yeah, and we got something. We definitely got something. So this is the parsed enum. If we check test DBML, this is exactly what we have here. I just forgot the space. Let's fix it. Where we parse enum. We print it. Yeah, so we have to do like this. Yeah, we got this space here. Cool. So we've parsed the enum. Then let's and but the thing is, I want to know if enum can have a node. Because I see tables may have it, project may have it, and other things, but enum. Let's check just here if can we node. No. So it cannot be here. Interesting. Well, can't do anything about it. So we would also not implement it anyhow. And I just cannot have a node, and that's it. All right, all right. So what's next? We have to just parse the table. There's nothing left much because we have schema, table definition. And as I said, we would for now just skip schemas and parse only tables like this. So they belong to public schema tables and enums as well. Yes, let's then try to do it. It's more complex. than enum for sure, but it is kind of similar. So let's go and do it. Let's have consume enum. Now we would have consume table. And we again consume. We again do something like this. Oh. Okay, I have to do it in the proper way. We are here. Yes, this we don't need. Okay, so if it's word or quoted, if it's not, we just exit, and we get our table name, consume it, consume the curly open, and now we go through columns. So column is just identifier, the type, table definition, can it have? Yes. Okay, so spaces are allowed, and this is a bit, see, it has supports all the types as long as it's a single word without spaces. And here's the example, but we actually can have spaces there. So this is solved. Those are settings. And column name might be also a double quote. Let's check it. So it can be a double quote, but it cannot be a single quote. Right, because single quote is just like a string value, but double quote is like an identifier. And you know what? I guess we got some repetition here, and I would do something like consume identifier, and it would return just string view, maybe rather a token. No, it would return a token. So it says basically like this. Oh, no. Yes, this one. Let me say if it's not, we just exit. Otherwise, we can here finally make it proper, make it more logical. So if we got something, we say we just say speak value, and we consume and return the identify, and yeah, we return the token, so it would be like this. And yes, otherwise we would exit. Here we can replace all of this and say or table name is consume identifier value. And here we do the same. So we say new unknown name is consume identifier. Value. Yes, and for now this consume identifier it only can consume one word or quoted thing, but for those it could be like something like this as well. Or even something like this. And for this reason we might even at this point already separate those, because and have something like we have this consume identifier, and we might something like token consume entity name. And for now we would just return basically the same, but later we might want to modify it so it would be able to consume those like things with dots, because we cannot have dots here. They are like single word identifiers. And I guess maybe just do consume name, just shorter. And can I just do how do I substitute vim search and replace? Okay, so it's double, it's this as I want to consume the fire with the consume name globally. Cool. Right. I hope it works. Oh, I had to make it consume entity name. All right. Okay, so let's fix it. It's consume file, consume entity name. Okay, and where do we use it? This consume project. And here we can also do oh, but it is this is optional. So yeah, here it is okay. Okay, so we don't touch it, we only do it here and here. I don't know why it was not substituted. Consume entity name. We consume the curly open. Now we have to parse the columns. So we say And for this, we might want to have actually either a structure, or we would just for now make a separate function to parse. So we say while peak and not peak is curly close. And here we do consume column. So here what we do, we say name is consume name value. Now we have to get the type. And it could be quoted something, or just like this. Could it have dots? Yes, but we would not. Could it have like, yes. All right, we wouldn't do it at the moment, but we would just use consume entity name like this. Because it might have like one or more of those parts it consists of. This is incorrect. Nested schemas and so on. All right. So we say auto name now. The type is actually kind of complex because we might have those things. So it's like the identifier plus optional arguments. So let's then using type or data type is a pair of this identifier plus a vector of basically anything. It could be numbers, so that would be just vector of string views, those be arguments. I hope you don't hear the sounds outside. Okay, and we say data type, or we would do like instead of data type, yes, and we say now data type, and we do it just like this, consume entity name value, and this one would be just initialized as empty. I hope so. And now we say if click is paren open, then we consume arguments. So we consume and while, actually this comma should be, could we have, no, okay. I thought like you can have just a comma at the end, but no, we have to handle it somehow. So first we consume just the first argument, and then we consume while we have a comma and something else. But basically we consume until the closing one, because I guess we cannot have something like this, or yes. So what we do is while peak and not peak is why it's not a closing paren, we just consume arguments. And if it's not the first, so we say we have to consume a comma. We will do probably with if data type second, if not data type second empty, it means it's not the first argument. Then we say consume, so we require this comma, and we all just do data type second I guess we just made it a bit harder at the moment. Let's just do it's just this one, and args. Yes, and we just say then if not args empty, and now args push back. Peak value, although we might want to check, so if not peak, then we just also exit, and here we get its value. Value, right. And I know we have some restriction probably on what we might have here, so it's definitely not all the tokens. It might be something like this, yes. And just a word, it could be a number. It couldn't be a dot, it could be something like here, something like here. Could it be an expression? No. All right. Could it be a multi-string? Yes. So it could be any string or number or word. And we might want to check it here. So if not peak is any string, or not peak is word, or not peak is not a number, then we just exit. And we here consume this curly close. Oh, no. We consume brand close. Yes. So this is optional. And inside of it, we might have empty parens as well. This is also valid. It will give us 0 arguments, because if it's the case, this would fail because the peak is actually paren close, and we will just skip everything and just consume this paren close and move further. And what might we get? We might get the settings of the column, and though those are kind of predefined, so it's not like there's arguments, we can have an arbitrary amount of them. Instead, they are strictly defined. What are the column definition, column settings? Yes, so this node primary key, if it's a null, I mean nullable. If it's unique, whether it has some default, auto increment, and check. Okay, let's then do it. So what we do is, so I would say settings. This I would say arcs, type arcs actually, and this is settings. So we do what? We just check if there is curl, not the bracket open. So if peak is bracket open, but here we would have to define all of those things. So we say optional node, boolean. I would say bool is primary key and it is false. Now bool, it's nullable, not nullable, and it is true by default. If it's unique and it is false by default, optional then string view default. Oh, we can't probably use it, but okay, the default value. And we would get there at the moment. It could be a number, string, expression, or a boolean. All right. So it even might be a token instead of just a string view, but for now, let's keep it simple. Whether it's increment, so bool increment, and like this increment, and it's false by default, and check. So, and we have to do be optional. Check. Okay, so we do what we consume, and we say while peak and not peak is token type bracket close, we either just we might get one or two of those. We say if peak is, it's a word, then we'll do like if it's for example what, let's call it maybe a key. So if key is node, then consume it, we consume token type colon, sorry, colon, and we consume any string. So if not peak is any string, we just exit, and otherwise we set node to peak value. Okay, if it was a node. Now else if key is pk, or let it be like this, then we just here we also have to consume. Now we might consume like at the end of this loop. Or no, okay. Yes, we consume and we have something like those columns. If it's a pk, then what we say primary key is true. Else if it's primary, then we would have to check if the next is word and it's a second, so if consume word value is not key, and we exit, otherwise we set this primary key to true as well. If it's unique, then we set the unique, what else? Unique, null or not null. Okay. So else if and then we null bool is true. Else if key is not, then we do something like here. We might want to reuse it. So if it's not, now we exit and we say null to false. Now let's do the default. Else if key is default, we consume token type colon, and here we consume what could be the default value: number, string, expression, or boolean. So we consume the colon, and we say token value is, oh no. If it's a number or if it's a string, and could it be a multi-string? Yes, but it cannot be a quoted one. It can, so it's just an any string. So if pick is any string or expression, or let's leave it for now. So if it's like this, then default value is peak value. Else if peak is word, I would say literal fun. I don't know, is it correct? Do we have no, we don't have it. So it's this, and we check if it's true or false or null. We set it, otherwise we exit because it's not supported. Else we also exit. And we consume. Yes, increment. This is simple, just like this. This increment, then and check. So check could be an expression. Oh, multiple checks might be defined on the column. So I can have check this, check this. All right, so check is actually a list. So it's vector of checks. So if it's a check, then we consume the column, and by the way, this consume type, it returns it or not? No. We should return the token here. Return token, because I guess maybe somewhere I already use it, like it returns a value but just didn't saw it. Oh yeah, yeah. I do it here. Okay. We say checks pushback consume expression value. And else we just exit again because it's some unsupported keyword. So if it's a token type, anyway, jump from, okay, so okay. If it's a word, then because it cannot be anything else, right? Right. So we might want to unindent it and say like or remove this, or actually let me first jump to this, remove, and now go here and unindent all of this. Yes, and this would be key is consume word value. Okay, so this is the end of the function method. So we would now write, just print it. So 1, 2, 3, 4. Now name, or how it's called, name. Yes, it's name, data type, and args. Name, data type. Now if not args empty, then opening and first arg. Just right but skipping the first one. And I also forgot for std. So we just print comma and what's inside of this arg. Closing one or yeah, closing one, correct. Now we go through settings, and it would be I would do something like boolean has any settings is set to false, but here I would say has any settings to true. And check now if it has any settings, and I would print all of them with the space. And now in what order? Probably just like they are here listed, but now it is not the first one, so let's go primary, null, unique, or primary, unique, not null, increment. So if primary key, then default check. If we've got any checks, and and we got note. Mhm. Mhm. Yes. Really big function actually. You might want to split it at some point. You say consume column. We'll basically do this. Consume column. And here we do close it. Mhm. Mhm. And end line. Let's see if it builds. Consume identifier. Where it is? Oh yeah. Should be consume name. Or else oh yes. So this is the line. This one. Okay. Forgot to add argument to exit. Let's check if there are no other exit. No. Okay. What else? And I put too much of those. Okay, now what? STD vector. Mhm. And primary key, I wrote primary key. All right, let's then try to add some column even from here. So those are valid. Oh, and we got some infinite loop somewhere. Not cool. Oh, yeah, I forgot to add it here. If it's a table, then we consume table. Otherwise, we would even add some error. parsing of, or like unknown entity. Cool, and yeah, we got to do it lowercase. Because for now we can't do it in the parser itself. And did I forget to? Or it might error when we parse it users. Quite interesting. Why? But at least those got correct. The primary key is parsed well, so it's either node or not null or checks. In checks there should be a comma as well. Or I mean there should be commas between do we do it between those things? It's kind of harder because for now we cannot say if it got any we might instead do like number of settings, and in the loop at the end do this, and here we also check if it's not 0. And what it gives us, this not for here, instead is it's not bracket close. So we say if we already got something, we should consume a comma. It's still errors. Okay. Don't have any arcs, so it's not probably here. Yeah, the absence of errors is, I mean, error messages is kind of bad. Let's probably add some. So here we would say expected, and we need string type. Not got, and if peak, and then to string peak value type, otherwise end of string. I guess it's not from here. Yes. From somewhere else. So consume table where we have errors. This is table args. Not the problem, it's somewhere here. Expected key after primary. Expected any string note. Expected after not. So it doesn't throw an error, but instead it just finishes here because it printed the users, but it stopped on this primary key. Did I consume the... Oh, no, I don't have to consume anything here. Or do I? So if it's bracket, oh wait, let's not bracket close. Yeah, I have to consume. Yes, so I just forgot to consume this bracket, the closing bracket, and it stopped there for some reason, not but for a logical reason, because it saw something else. It saw actually, and then it just exited. Let's see where it was. Consume table, and it was this bracket. Yes, I forgot to consume the bracket. This one, and it just stopped there and didn't proceed to further columns. Interesting, but now everything is good. So we parse the tables, and let's see how good we did it. So we have followers, and we created timestamp, all good. Now users. The only thing I might do is where we print it. We might a little bit modify it to know if we should print a comma or not. Still we got something, then we do this. And we do it everywhere. But here maybe a bit differently. Here for sure we don't do it. And now we have to, yeah, because here we might want to do it like this. Now we have to do it everywhere. Yes. Let's see if it works. No, no, it doesn't. I thought we can just decrement each time we print some settings. We can decrement this, and if it's still not 0, so if we got something left, we would print the comma. Otherwise, we would just not print it. And we decrement it everywhere. Maybe we got some overflow. I don't know. Really, it's interesting why we got like multiple commas. Oh, because I know why. Yes, I forgot to remove the printing of comma everywhere. Yes. This is good, this is good. Remove from increment from here. Remove from primary already. Yes, yes, cool. This thing works. Fantastic. So we managed to parse tables, even all the settings. Still not sure. We have to double check if we really parse all the settings and do it correctly. But in general, we managed to parse it and we managed to store that, so then we can print it. It means as we store it, we can make some structures for them, classes, structs, whatever, and store them as objects, and then they could be somehow used. I don't know for what purposes, but anyways. So that is probably it for today. We did a really big chunk of job, actually. We managed to parse tables. They are the hardest. Although, yeah, I know we for now only parsed columns. And there is a lot of things in tables apart from columns. So we might have, let's check table definition, nodes. There might be aliases as well. Settings, columns, right? Default checks like this, indexes, and so on. So there, yeah, relationships. So there's a lot of going on, but we have a really good start. We parsed the columns, and columns themselves, they're really complex. They might have a lot of settings with them associated. Maybe, just maybe, but that's for sure we would have to handle, so we cannot specify some things multiple times. For example, we can specify checks multiple times, but everything else should be only one time. If we specify it multiple times, can we work this? Yeah, primary key can, oh, it says even either. What if we do primary key? Says it's a duplicate. Yes, so we have to check. And the way I might, I already think we can do it is, let me get into primary key. How primary, right? Yeah, primary key. I might do all of them optionals, like with node or default value. And when I encounter one of those, if I see that this unique, which would be optional, is not set, then I would throw an error. Otherwise, I would just set the value for it. This way, we can check if we got this setting already, and then throw an error. Yes, so this is the way how I see it, what we might do it for the settings themselves. Now, we also would probably like at some point to fix the errors, because the way they are done at the moment, it's kind of horrible. I would do some at least helper function that would print for me those red start and clear the color of the console at the end, and would print anything here. Maybe we would even research a bit and try to do it the way how printf works and use it there. So our error or a fatal or exit, whatever function we would name it, it would have this variable number of arguments that we can pass into it. And there would be like first argument as a format, a template string, and then what to put in the, like we do it for printf, but except we would have this extra things at the beginning and end, and also this exit, and we would print into cerr, not std cout. Yes, this is what I see at the moment. And also there's a lot of things we might also need to take care of, but for now, as I said, this is really good progress at the moment. What I did. Yes. This is really good progress. We parse table columns. And yeah, this is it for today. I hope you like it. So thumbs up, like, subscribe, share, you know what to do, and see you in the next one.